Dear students, again welcome back for the 10th session of this physical concept called as the solutions. So in the last various sessions, we have discussed the three different colligative properties called as lowering of vapor pressure, elevation of boiling point, and finally the depression in the freezing point. All we have proved that they are the best examples related to the which one? The colligative property, because all those physical properties depends only upon the which one? Number of moles of the solute particles present in it, but not upon its either the size or it will be the chemical nature, but on and also not on the solvent. They strictly only on which one? The solute. That is why, and also they are applicable with respect to the dilute solution, but not for the concentrated solutions. Okay. So now we will move on to the fourth property, that is called as fourth colligative property, called as which one? The osmotic pressure. So before moving to osmotic pressure, let's have the clear idea related to what is osmosis. What is osmosis? So here, suppose if I take a glass container, or the U-shaped glass container, we are saying that. Okay. So here the two limbs are filled with the two different solvents, which are separated by means of which one? Semi-permeable membrane. This is called as SPM. What is that SPM? Semi-permeable membrane. Means the membrane or the sheet which can allow only the one type of particles but not the other. Means if among the two solute and then the solvent are present, means the two particles are present, only the solvent has to be move but not the solute. So that property is called as semi-permeable membrane. Means semi means half. Means it also allows the only the smaller size particles but not the larger. That is why it is called a semi-permeable membrane. So let us take. So here, this is a pure solvent. This is a solution. What's the meaning of that? It is not a mixture. Here it is a single component, that is a liquid in the form of pure solvent. But here, this consists of both the solute and then the which one? Solvent. Solute and then the solvent. Okay. After some time, and these two are separated by means of which one? The semi-permeable membrane. Okay. Now what happens here? After some times, slowly the level with respect to this goes on increasing, and simultaneously the level with respect to the another limb, that is the solvent limb, goes on decreasing. And this is a best example for a spontaneous process. It has not done on its own. It is a spontaneous process. So why the level with respect to the solution limb goes on increasing, whereas the solvent level goes on decreasing spontaneously? Means this gets lifted, means there is some movement of which one? Only the solvent, because there is a pure solvent here. Here, can I say that 100% of solvent is present here? Why? Because it is pure solvent. Here, if it contains X% of solute, means can I say it is 100 minus X% of solute, solvent? Why? Because it is a mixture. Means we are having the high concentration of the solvent. Here, the concentration of the solvent is going to be less. Here the concentration of solvent is maximum or it is 100% because it is pure. So there it is going to be the less than 100%. Means where the solvent molecules will start to move from the region of its higher concentration to the lower concentration through the what membrane? Semi-permeable membrane. The process is called as which one? The osmosis. Means it is the process of movement of or mobility of the solvent molecules from the region of its higher concentration to lower concentration through SPM. What is SPM? Semi-permeable membrane. Semi-permeable membrane. Or I can define this also. It is also the process of movement of the same molecules like solvent molecules. Same process. It is also movement of which one? The solvent molecules. From the solution of lower concentration to solution of higher concentration through again SPM. But here it is having a different definition here, but both have the same meanings. Here I mentioned from high to low. Here I mentioned from low to high. But what is the difference here? In defining the first one, other in the first statement, what is that? We are not used any solution term. We are not used any. Means it is a process of the solvent molecules from the region of its. Its means again the solvent. Means solvent concentration is higher, means solution concentration is lower. 2. Higher concentration of solvent means, what is the meaning of higher concentration of solvent means? It is a lower concentration of which one? Sorry, from higher concentration of solvent means it is the lower concentration of solution. To lower concentration of solvent means it is the higher concentration of the solution. Means if I use the word as a solution means we have to mention low concentration to high concentration. Suppose if I am not using the concentration term, the solution term means it is from higher concentration to the which one? Lower concentration through the same medium that is called as what membrane? Semi-permeable membrane. Means it is a flow, or it is also called as the movement of which molecules? The solvent molecules from the region of its higher concentration to the lower concentration through the semi-permeable membrane. So in the first definition I have not used any solution term here. But the same movement or flow of the solvent molecules from the solution of, I am preferring the word, what is that? From the solution of which concentration? Lower concentration to the solution of higher concentration through the same semi-permeable membrane means the process is called as which one? Osmosis. High to low and low to high. High to low means don't use the solution term. If you want to use a low to high means we have to use strictly the what term? The solution term. But both has to move through the semi-permeable membrane. That process is called as which one? Osmosis. Okay. Now, as it is a osmotic, what is that? So here we have to be very clear first. Semi-permeable membranes are of two types, either it may be the natural or it may be the synthetic or it may be the artificial. First, what is semi-permeable membrane? A thin membrane or the sheet which allows only the flow of the solvent molecules but not the solute particles, or which allows only one type of the smaller size particles but not the larger size particles. That membrane is called as semi-permeable membrane. The examples related to this one is parchment paper, then we are having the goat bladder, sheep bladder. What is that? They are the naturally occurring semi-permeable membranes. But we are having an artificial in the form of either we should have the cellulose acetate or it may be the cellophane. Cellobios also we can have. What these are? They are the examples related to the which one? Artificial, or it is also called as synthetically semi-permeable membrane. Means the sheet or the membrane which allows only the smaller size solvent molecules but not the larger size solute particles, and particular membrane is called as what membrane? Semi-permeable membrane. Okay. Now, suppose, as if we know that the level with respect to this goes on increasing and the level with respect to the solvent goes on decreasing. Suppose if I apply the pressure, if I apply the what? Pressure, using the help of a piston for example, by applying the pressure on the solution side, what happens? The level with respect to both the solvent in the first limb and then the solution in the second limb remains the constant at some pressure. And that pressure is called as osmotic pressure. Means we are avoiding, what we are avoiding? For the movement of the solvent molecules from the region of its higher concentration to the what concentration? Lower concentration. So to prevent that spontaneous movement of the solvent molecules, we have to apply an external pressure on the solution side. such that there is no flow of the solvent molecules from the same region of higher concentration to the lower concentration, and what is the extra pressure that we have applied is called as what pressure? Osmotic pressure. Therefore, how to define that? It is an external pressure applied on the solution to prevent the process called as osmosis. Just we are preventing the which one? Osmosis. Why? Because osmosis is the best example for a what process? Spontaneous process. Means on its own, what happens? The solvent move from the region of its higher concentration to the which one? Lower concentration. To prevent that movement of the solvent molecules, what we have to do? We have to apply an external pressure on the solution side. So due to the applying of the solution, external pressure on the solution side, what happens? The flow of the solvent molecules will start to block. Means there is no movement of the which molecules? Solvent molecules. If there is no movement of the solvent molecules, means we can't expect any process called as osmosis. And that particular pressure is called as what pressure? External pressure. Means it is always an external pressure that has been applied on the what side? Solution side, just to prevent the process called as osmosis. Or we can define in another way as, it is an hydrostatic pressure. It's an what pressure? Hydrostatic pressure applied on the solution to prevent the flow or movement of which molecules? Solvent molecules. To prevent the flow of which molecules? Solvent molecules. It is a hydrostatic pressure that has been applied on the solution to prevent the flow of solvent molecules from the region of its higher concentration to lower concentration during the phenomenon called as, what is that? Osmosis. Means indirectly we are preventing the osmosis. How to prevent the osmosis? Just we have to prevent the flow of solvent molecules from the region of what concentration? Higher concentration to the lower concentration. Means, and that hydrostatic pressure, why we are using the external pressure as hydrostatic here? Hydro means water. Stat means constant. Means we have to keep the solvent constant. Means there should not be a movement between those two through the what membrane? Semi-permeable membrane. That is why we are using the word as what pressure? External pressure is found to be the hydrostatic pressure that has been applied on the what side? Solution side, just to prevent the flow of which one? The solvent molecules from the region of what concentration? Higher concentration to the lower concentration through the semi-permeable membrane during the phenomenon called as what? Osmosis. Okay. Now, water, for example. Concentrated acid, for example, HCl. Okay. Now, this is a solvent, that is also a solvent right now. If I put almond, badam in Kannada we are calling. Okay. So in this I am putting the which one? Mango, for example. This is mango. What happens here? What happens after some time? So here the size with respect to this, if I put it in the evening, or it may be the night, that is sample of, or a small piece of which one? The badam. And if I see in the early morning, what happens? It starts to swells out. Means it becomes larger in size. Means it's swelling. So here, with respect to this, it gets collapsed in its size, means there is a decrease in the size with respect to the mango, means it gets shrinked, I think. Here it swells, there it gets shrinks, and both are due to the process called as which one? The osmosis. So what is the meaning of that one? So here, the outer cover of this particular is called as SPM. The outer layer with respect to that particular is called as what? The SPM. What that SPM will do here? Here we are having the pure solvent, here also we are having the solvent to a little extent. Therefore, the solvent will move from the region of higher concentration to the lower concentration. So this is called osmosis. That's also osmosis. Why it is? Here, this is exosmosis, and this is called as preferably the endosmosis. Endo means out, whereas exosos means which is in. Endo means in and exo means out. So here, the water droplets that has been present inside the mango, what happens? It will move out through the semi-permeable membrane, such that the solvent will move into the concentrate, because as it is a concentrated means it is having more amount of a solute but less amount of a solvent. Usually during osmosis, what will happen? The solvent will move from the region of higher concentration to the lower concentration through the what membrane? Semi-permeable membrane. So here, the water droplets that has been present inside the mango will start to move into the container. That is why it starts to get swells out. Means water will move out. Out means it is called as exosmosis. During exosmosis, what happens here? There is a shrinking of that particular mango will takes place. So here what happens? He is as if the amount of the water content or the moisture content in that particular almond is going to be very, very less. But outside it is rich with which one? Solvent. Therefore, what the solvent will move here? Into the almond. So what happens there? It starts to get swell out. Means the water has moved inside. Inside means it is called as endo. That is why it is called as what osmosis? Endosmosis. Means if the solvent moves from the particular system through the semi-permeable membrane outside, or if the solvent moves out means it is called as exosmosis. If the solvent moves in means it is called as endosmosis. Okay, so that makes a difference here, because here we are having the swelling nature of that particular almond, whereas where we are observing the shrinking of the mango, because it is put in. Suppose if the same mango is put in the water, it also gets swells out. But as if it is preserved in concentrated NaCl or a concentrated HCl, what happens here? It starts to get shrink out. Why it is shrinking means because the solvent, that is the water that has been present inside of the mango, ripe mango, it will start to move out and enter into the concentrated NaCl, or it will be the HCl. That is what is called as exosmosis. Okay, whereas this is going to be the what? Endosmosis. Okay. So this is about the first definition related to the which one? Osmotic pressure. Now we will have the proving of which one? Colligative property with respect to osmotic pressure. Let us have the reverse osmosis also. Let's make this one very clear, and then we'll move on to the proving of colligativeness. The same thing. This is as usual what? SPM, semi-permeable membrane. This is the pure solvent. This is the solution. Okay. Simultaneously, what happens? The level with respect to this goes on increasing, and the level with respect to this goes on decreasing. That process is called as which one? Osmosis. To prevent the process called as osmosis, what we have to do? We have to apply an external pressure. External pressure. Where the external pressure, which is equal to the what pressure? Osmotic pressure. There is the maintaining of these two remains same. Means we are using the what, or we are preventing the osmosis. The process is called as, the pressure applied is called as what pressure? Osmotic pressure. Suppose if P greater than pi, suppose if I press hardly, that hardness is greater than, or the pressure that we have applied is going to be greater than the what pressure? Osmotic pressure. The solvent molecules will move from the solution to the solvent. Therefore, the level with respect to this increases, and the level with respect to this one, and this is called as reverse osmosis. Then how to define that reverse osmosis here? It is a pressure greater than, it is a process of, first we will have the definition first. It is a process of movement of which one? Movement of which molecules? Solvent molecules from the region of its lower concentration to higher concentration through SPM, semi-permeable membrane, by applying a pressure greater than, what's that? Greater than OP. What is OP here? Osmotic pressure. Means, if I didn't apply the pressure, what happens? The normal width takes place, the osmosis takes place. If I apply the pressure which is exactly with the prevent the osmosis, means it is called as what pressure? Osmotic pressure. Suppose if I apply the pressure which is found to be greater than the osmotic pressure, what happens? The reverse can take place. What that reverse here? The solvent molecules will start to move from the region of its lower concentration to the which one? Higher concentration. From the region of its lower concentration to the higher concentration through the what membrane? Semi-permeable membrane. And that is called as exactly reverse to the osmosis, and that is why it is called as what process? Reverse osmosis. Okay, reverse osmosis. So the best example that we have discussed are, the main application is in the by RO treatment we are calling reverse osmosis. What we are drinking right now, the purified water through the RO systems. What is RO here? Reverse osmosis. So here we are having the tap water. Usually the tap water is a salt water, where it contains a solute in the form of dissolved solutes with the pure liquid that is called as water. But we are softening that. How? By removing the what particles? Solute particles. How it is? By applying the pressure. Only by applying the external field or electric field, which is greater than the what pressure that has been required here. The osmotic pressure, what happens? The solvent molecules will move from the tap water or the borewell water, and that has been converted into 100% of pure water, and that phenomenon is called as what treatment? Reverse osmosis, or the treatment is called as the desalination of water. What is desalination? Removal of the solute or the salt particles from the sea water with the help of what treatment? Reverse osmosis treatment. Okay, so that I will describe laterly about the which one, how we are purifying that particular sea water into a pure water. Okay, so this is about the which one, the reverse osmosis and then the osmotic pressure. Now we have to prove that it is an example for a what? Colligative property. How to prove that it is an example for a colligative property? So before proving, now we are concerned with which one? The Van 't Hoff's theory of dilute solution. What theory here? It is the Van 't Hoff's theory of dilute solution. Before proving that one, let us have another concept in the form of isotonic solutions and then the isotonic solutions. After that we are having the isotonic, then the hypertonic solutions, and then the hypotonic solutions. Okay, so here let's have the term related to that in the form of which and which, the isotonic, and then the another one is the hypertonic, and then the hypotonic. Okay, let's make very clear first this, and then we have to prove that it is an example for a what property? Colligative property. This is SPM, semi-permeable membrane. This is the pure solvent, and this is a solution. Okay, so instead of this, no doubt The level with respect to this goes on increasing and this goes on decreasing, and that is going to be the what? The osmosis. And whatever the pressure that we have to apply for this, what happens? The solvent molecules not move from the solvent to the solution. To prevent that osmosis, we are calling that pressure as what pressure? Osmotic pressure. Now, if I take for example 0.1 molar of C6H12O6 solution, if I take 0.1 molar C12H22O11 solution, what happens here? This is glucose solution having a formula C6H12O6, and this is having that is also a 0.1 molar sugar solution or sucrose solution. Usually glucose and sucrose are non-electrolytes, means that doesn't, means how many particles are there? Only one particle, because it is a non-electrolyte. There it is a non-electrolyte. Okay. Now, where the solvent will move here? So here glucose plus water, here sucrose plus water. Here glucose and sucrose are solute and water is a solvent. What is the concentration of solvent in both the cases? See, why? Because we are having the 0.1 molar, means what is that? 0.1 mole of an electrolyte or a substance is added in or dissolved in 1 dmg the solvent. Means what is the amount of the water in both the cases? It is going to be the same. Means there is no osmosis. Means the level with respect to these goes on remaining the constant, because they are called as what solutions? Isotonic solutions. Means the solutions having the same osmotic pressures are collectively called as what solutions? They are the isotonic solution. Any solutions which is having the what? The same osmotic pressure, then it is going to be the what? Tonic, isotonic. Here blood is isotonic with 0.91% of NaCl solution. What is isotonic here? The blood is isotonic with which one? 0.91% of what Cl? NaCl. What's the meaning of that here? So blood is a buffer actually, which is a phosphate buffer or a carbonate buffer with water, in contact with 0.91% of which one? NaCl solution. Means through the veins, usually we are calling that as which one? Intravenous, IV. They will supply the what? The glucose, or it may be the any sodium salts, or it may be the potassium salt. So for example, 0.91% of NaCl has been injected through the veins. What happens? So there is no swelling with respect to this. Why? Because the blood what we are having, it is having the same concentration, or it is having the same osmotic pressure as compared to the top 0.91% of NaCl solution that we have taken inside. So here that particular nerve is considered to be the semi-permeable membrane, which allows the both, such that both are having the same concentration. If both are having the same concentration, means both are having the same what pressures? Osmotic pressures, and that particular solutions are called as isotonic solutions. Whereas, suppose if I take for example 0.1% of 1 molar of NaCl solution, here 0.1 molar of glucose solutions. Here these two solutions are not isotonic, because this consists of Na plus and Cl minus, because the colligative property depends upon the number of moles of the solute properties, particles, but not the solvent. So here it is 0.1 into 2 particles are present. What are the 2 particles here? NaCl, that is equal to 0.2 molar. So here 0.1 into, as glucose is a non-electrolyte, means it doesn't get ionized, therefore the number of particles is 1, that is equal to 0.1 molar. Whether the molar concentrations are found to be same or different here, they are found to be the different. Means this is higher concentration, means this is lower concentration. Lower concentration means more concentration, therefore the level with respect to this gets increased and this gets decrease. Means we can expect the process called as osmosis. Means these two are not isotonic. What is that? 0.1 molar of NaCl and 0.1 molar of glucose is not isotonic. But 0.2 molar of glucose, if I take 0.2 into how many particles are there? 1. Therefore, it is equal to 0.2 molar. Means what is the molar concentration of the solute that has been present in the two different solutions? They are found to be same. Means the solutions having the same osmotic pressure means same. Which concentrations? Molar concentrations. Any two different solutions which is having the same molar concentration with respect to their individual particles, they are found to be what in nature? Isotonic. Isotonic. So let us take another example related to this. Zero point 3 molar, 0.1 molar of barium chloride with 0.15 molar of potassium bromide. Therefore, to be the isotonic. Why? Because 0.1 into how many particles are there? 1 barium and 2 chloride. 1 barium and 2 chloride means how many particles are there? That is equal to 1. This is 0.3 molar. But here 0.15 into how many particles are there? K plus and Br minus into 2, that is equal to 0.3. Means these are the examples with respect to which one? The isotonic. Means the isotonic means first they must have the same molar concentrations with respect to their individual particles. Suppose if it is not electrolyte, there is no worry. But if it is an electrolyte, you have to count the number of particles present in this. And then if their molar concentrations with respect to their individual particles are found to be same, means they are having the same what pressures? Osmotic pressures. Any solutions which is having the same osmotic pressure means they are found to be the isotonic. For isotonic solutions, there is no movement of the which molecules? Solvent molecules from the region of its higher concentration to the lower concentration or lower concentration to the higher concentration. Means they doesn't undergo a phenomenon called as which one? Osmosis. If osmosis is not possible between the two different solutions having the same molar concentrations or having the same osmotic pressure, means they are considered to be the what solutions? Isotonic. Okay. So let us have the another two in the form of what? Hypertonic and then the hypotonic. A solution in which our solution having a higher osmotic pressure than its respective solution, then it is considered to be the what? Hypertonic. Hyper means more. If it is found to be the lower means, then it is found to be the what? What is that? It is hypotonic. So let us take blood placed in greater than 0.91% of NaCl, blood that has been placed in less than 0.91% of which one? NaCl. 0.91 molar percent of NaCl, sorry. 91% of which one? NaCl. We know that blood is isotonic with 0.91% of what? NaCl. Suppose if that blood, if it is placed in what? The sodium chloride concentration which is greater than 0.91%, means it is having higher osmotic pressure right now. So here, can I say that the water that has been present inside the blood will start to move here. This blood cells starts to shrink due to the process called as exosmosis. What is that? Exosmosis means the solvent will move out from the blood cells such that the blood cells get what? Collapsed, or indirectly they get shrinks, which is due to the phenomenon called as exosmosis. And those type of solutions are called as what solutions? Hypertonic solutions. Similarly, blood is placed in less than 0.91%, means here the solvent concentration is more here, because it is greater here means solvent is more. Solvent is less here. Here less concentration means more solvent, means the solvent will move here. Means the water from the sodium chloride will enter into this one. Therefore, this blood starts to swells out. Blood also swells out, and that swelling nature is due to the endosmosis. Means the water has comes inside to the blood cells. What happens? It will start to get expanded, or indirectly it is called as swelling nature, and that swelling nature is called as what osmosis? Endosmosis, and that particular solution is considered with the what tonic? Hypotonic. Isotonic, hypertonic, and then isotonic. Okay, so hypotonic. What's that? The solutions which is having the same osmotic pressures are having the same molar concentrations are collectively called as what tonic solutions? Isotonic. The solutions in which the solution has been placed in the solution which is greater or having the higher osmotic pressure, then it is called as hypertonic. If it is having the lesser osmotic pressure than its respective solution, means it is called as what solution? Hypotonic. In hypertonic, the exosmosis takes place such that the system or the solution will start to get shrinks out. Whereas in case of the hypotonic solutions, what happened? The solution or the system has to undergo a process called as endosmosis that will start to get swell out. Okay, so these are the three different solutions with respect to the phenomenon called as which one? The osmosis. That is isotonic, hypertonic, and then the hypotonic. So which is behind the what? Exosmosis and then the endosmosis. Okay, so next in the last session, I think it may be the last session, if how we have to prove that it is an example for a which one? Colligative property. Means you have to prove that osmotic pressure is an example for a what property? Colligative property, and thus it is by a theory called as Van 't Hoff's theory of which solutions? Dilute solutions. From this theory we will decide which one? The osmotic pressure is the best example related to the what property? Colligative property. By the Raoult's law of which one? Raoult's law of liquid mixtures, we have proved that lowering of vapor pressure is a colligative property. By the graphical representation with respect to the elevation boiling point, we have proved that it is an example for a colligative property. Similarly, on the cases of the same, which one? The graphical representation, we have proved that it is an example for a what property? Depression of freezing point is a same property, that is called as colligative. But with the help of one theory, what is that theory called as? Van 't Hoff's theory of dilute solution, we are proving that osmotic pressure is an example for a what property? Colligative property. And also after proving that, how to get the molecular mass of a same solute with the help of another colligative property that is called as what pressure? Osmotic pressure. Because using LVP, using EBP and using DFV means lowering of vapor pressure, elevation of boiling point and depression of freezing point, we have calculated the what mass? Molecular mass. Similarly, with the help of another colligative property called as the osmotic pressure, now we are having the expression with respect to the same which mass? Molecular mass of the solute. Okay, so that all we will discuss in the last session related to the theoretical concept of the second chapter of physical, that is called as solutions. Okay, so that we will discuss in the next session of this solution chapter. Okay, so thank you.